Hey everybody. So this problem follows immediately from 1020, so you should watch that video first. So that's where we took the frame, broke it apart, and then solved for all of the reactions everywhere. And then once you do that, right, then the members of the frame, right, this one and this one, we know all the reactions everywhere. So for number 21, we're looking at the internal forces and moments at point B. So that's for this member of the frame here, in which we already solved all of these. C, D, E, X, E, Y. Okay, so we know all of these from earlier. And so now we have this distributed load, and we want to know internal forces and moments at B right here. So we want to cut the section like this. And again, what we don't want to do is take this representation of it and then cut the section through here. That is not okay. Okay, so the original representation with the distributed load, and then we cut it right here. When we do that, the section on the left, section on the right looks like this. And then like this, and like this. Okay, and then that reveals all the internal forces and moments. Axial force, bending moment, shear. Okay, now it's totally up to us which of these two sections we'd like to analyze. So whichever one looks easier. I think they look pretty much the same, right? Because there are 3 unknowns, and then we have these 2. 3 unknowns, and we have these 2. So I don't think there's advantage one way or the other. So how about this one? Okay, so we can write 3 equations for those 3 unknowns. So in the x direction, okay, let me move this over. Okay, so now that we have the section, you see this distributed load. Now that we cut the section, it's okay to represent this distributed load as a single discrete force. So we can replace this with a single force that is the area of the shape. So let me, okay, so this is 4, and here to here is 1 meter, right? Because B is over here. Here to here is 1 meter. Here to here is 4, which means the area of the rectangle is 4. And the location of that force is at the centroid of the shape. So at the centroid of the rectangle, which is 0.5 meter. Okay. And then write the rest of it. Okay. So now for this, I'm just going to erase this. Okay. So for this free body diagram, now some forces in X, some forces in Y, some torque about somewhere clever. So it doesn't matter how about over here, the right side of the section. Okay, so here to here is also 0.5. 0.5 meters, 4 kilonewtons, and then here to here's 1 meter minus 1 meter, EY, and then the couple plus M equals 0. Let me point out the unknowns here, right? Because we already know all of these. All right, so solve this for the axial force, solve this for the shear, solve this for the bending moment. Okay. All right, so keep on practicing. This requires a bunch of practice. I'll see you in the next video.